All right, we could probably get started now. Hey, everybody. I want to welcome everyone back for our second workshop of the semester. So this is our second of back-to-back workshops. Yesterday, we had our very first one, and in there, we covered some foundation and fundamentals of blockchain and what it is. Don't worry if you're not quite familiar with the idea of it. We're going to do a brief review, and as well, the workshop was recorded, so we're going to be posting that onto our website very shortly. So for this workshop, the topic that we're going to focus on is cryptography. That being said, I'm happy to be joined here with a fellow coworker and friend, Teddy. Teddy's a master's student at UFC and our director of project management at UCBS. So he's going to run you guys through some fundamental concepts of cryptography and consensus. And after that, Perry and I are going to take some time to run through a series of interactive demos that will help you get set up with your own wallet. They're going to get some test ether from a faucet, and then we're going to show a really cool demonstration of how a blockchain is actually working in real time. So as for the agenda for today, I'll quickly run through some of the topics that we're going to focus on. First, we're going to do a brief review from our previous workshop on blockchain. And next, we're going to take you through a series of topics to help you kind of understand the inner workings of cryptography. And that's going to involve public key cryptography, digital signatures, mining, and consensus algorithms. And after that, the last three topics that we have are going to be the interactive demos that Perry and I are going to run through to get started with your own wallet with something called Metamask. And then that nice visual demonstration of how blockchain transactions work with Transaction Street. So that being said, that's really it for me now, and I can pass it off to Teddy.
Oh, thanks, Paul. Thanks for the introduction.
Sure.
Yeah, I'll share my screen. Okay, can you guys see my screen?
Yep.
Cool. All right. So hi guys, thanks for coming to the second workshop. So we're going to start some review, kind of what we talked about yesterday. So we talked about hash functions. There's kind of the basic foundations of blockchains. It's pretty much the basis of how it all works. And then we transitioned into blocks, how we would get a hash from a block, what goes into a block. We were talking about how it has the block number, a number called a nonce, and then the data. And we kind of turned that all into a hash. And then we went on to talk about how it actually chains together and how that blocks contain a hash of the previous block, forming the blockchain. Then we were talking about tokens, which actually is the data contained within the blocks, actually has the transaction in there. And then we're talking about the Coinbase idea where you can actually have some type of value going from person to person or address to address for blockchain. So that's a small little review. It's very quick. If you want to have a little bit of a more thorough review, our first workshop is recorded. So feel free to check that out when you can. So I wanted to kind of dive a little bit into kind of the inner workings of blockchain a little bit further than what we talked about yesterday. So the first kind of key concept of blockchain is public key cryptography. It's also known as asymmetric encryption or asymmetric cryptography. There's also symmetric cryptography, and I'll talk a little bit about the difference between the two. And so what public key crypto is pretty much is that it's an encryption scheme that uses two cryptographically related keys. And the idea is that these two keys, there's a private key, which is only you would know the private key. You wouldn't share the private key with anybody else. And there's a public key. So everybody knows you by your public key. And so the goal with these two keys is that although people know your public key, it's almost computationally infeasible to derive your private key from it. And there's some really cool cryptographic functions that actually achieve this. So what it does is it provides confidentiality and integrity between two parties when they're talking to each other. And I'll talk a little bit about how it actually works in kind of in the real world more than from a blockchain sense. Actually, I'll talk about both. And then so there's a couple different algorithms that I mentioned. So there's RSA, There's the elliptic curve, digital signatures, and then a really popular one is at the bottom is the Diffie-Hellman public key crypto. And there's also a key exchange protocol that they invented as well, which is really cool. So definitely check it out if you're interested in public key crypto. So how do these keys work with blockchain? So imagine that the public key is something like your wallet address. And so everybody knows your wallet address because they have to send your transactions to some address. And so that can be known as your public key. For your private key, imagine that to be your seed phrase. And now whenever you create a crypto wallet, you are asked to create a seed phrase, and then that seed phrase will derive your public key. So they are related, but you would never ever share your seed phrase with anybody. And then at the end of the day, your private key is what is going to verify the transactions that are sent to your public key, which is your address. So kind of seeing it in action, just kind of in the real world. So if I'm Bob, I'm sending a message to Alice here, and I'm going through the server. And so I have Alice's public key. So I'm going to encrypt a message to Alice using her public key. And then so in transition, it's going to go to Alice. And then when Alice gets the message, it's encrypted with her public key. Now, the cool thing about public key crypto is the only thing that can decrypt that message is her private key. So I can't even decrypt it with her public key, but I know what I sent. And other people know her public key, but they can't actually decrypt it. It's only her private key can decrypt it. That's kind of the mathematical magic that's going on with this public key crypto stuff. So it's really interesting to see it used here. And then it's also used a lot with blockchain as well. So that's kind of a little intro to public key crypto. It's very high level. If you're interested, please do some more research on your own, as it can kind of get really cool once you start to dive a little bit deeper. So now I'm going to talk about a little bit about digital signatures. And so this kind of plays on to kind of the public and private key concepts. And so what are digital signatures? They allow us to use public key cryptography to provide message authentication between two parties. So it's like similar to real world signature, where if you were to send a message to somebody, you would sign it at the end to kind of signify that it's you that's signing it. Of course, someone could maybe forge your signature, but that's just an assumption that we have. So we have kind of two keys again. We have a signature key that's used to sign a message, and then we have a verification key to actually verify the signature. So how is this related to blockchain? Transactions are actually encrypted using the person who you're sending to's their public key, and then the transaction is actually signed by the private key. So the sender signs the transaction with their private key, and then you can verify that that person actually sent their transaction using their public key. That's kind of how it works that way. So you have the transaction is separate from the signature, and they're kind of sent together. And this is typically something that the nodes perform. So it's not your really responsibility, but if you download like a mining software or something, it'll do it for you. And also like a wallet like Metamask would do that for you on the fly as well. That's kind of digital signature. So kind of here's an example kind of in the real world is I'm Bob. Again, I'm sending a message to Alice. I sign the message at the end with my private key. And then Alice can verify it using my own public key. And if it checks out, then he knows it's from me because only I own the private key. Now, again, this kind of could get compromised. Let's say somebody else steals my private key, but that's a different issue. You're kind of compromised at that point. So you have to make sure to keep your private keys safe. Yeah, so from that, we'll kind of move on into more of the consensus and to mining a blockchain. So with mining is essentially just a common process where, you know how yesterday we showed in the demo, we had all those blocks in a chain. Mining is the process of actually adding new blocks into the chain. And it's essential to kind of the security and integrity of many, if not all, cryptocurrency protocols. And one of the biggest things it allows for is it allows for the prevention of what's called double spending. So it's essentially like if I were to change a ledger saying that I spent 10 ETH on something, and then, I was able to send myself back that 10 ETH, then I have that something I bought, and then I also have my 10 ETH. So it's like I got it for free. So this kind of validation, this mining process allows for such things to not happen. And there's kind of different consensus mechanisms that are used for these mining blocks. So we're going to talk about proof of work. We're going to talk about proof of stake. And then we also have another one, proof of history. And I think that's one that Solana uses. We won't be talking about that much, but that's more so verifying timestamps of blocks. So we're going to move on a little bit to consensus algorithms now. So what's a consensus algorithm? It's a procedure in which all the peers of the blockchain network can reach a common agreement about the current state of the distributed ledger. So it's essentially, when a block gets added into the chain, most of the nodes have to agree, depending on the protocol, the nodes have to agree that that node is valid, and that once it's validated, it's on there forever. So because blockchain is peer-to-peer, there's no central authority. This is something that's a key core component of blockchain, because we have to make sure that we're able to achieve trust between each node. And we need to make sure that we're reliable with what we're putting on that chain. So oftentimes if you see a blockchain kind of get compromised, it might fork over to a new chain and then leaving that compromised chain kind of in the dust. So there's kind of two consensus algorithms that we're going to talk about, and they're kind of the two most popular ones right now. The first one is proof of work. So this is something that Bitcoin uses, and what it does is it's essentially miners are trying to race to perform some computational work to solve a math problem. So kind of like we looked at yesterday with that mining process of trying to get the nonce to make sure that the hash had 4 zeros at the beginning. That's essentially what this proof of work concept is. So miners are racing to kind of find that nonce value that will produce it has to produce some solution to a problem. And with Bitcoin, particularly, is that their problem, I believe, is the hash value is continuously getting smaller and smaller and smaller. So it's getting exponentially harder to find that nonce value. So there's kind of two main features of proof of work, is that in order to validate a block, it's got to be pretty hard to do it, because we want to make sure that the block is kind of secured, and we want to make sure it's not easy to validate it. But once the solution is found, we want to make sure it's easy to verify the solution, and that can be done kind of going through the blocks and ensuring that all the hashes line up. And then you have also the majority protocol as well to make sure, like the voting system that we had. So Bitcoin's problem is like the very, very abstract version of it is like, given data A, find a number X. So X is like the nonce that we're looking at, such that the hash of X appended to A results in a number less than B. So it's essentially what this is saying as more and more blocks are getting added to the Bitcoin blockchain, that hash has to get smaller and smaller and smaller. And it's up to the miner's job to find the nonce that will validate that block. That's proof of work. So proof of stake is something that Ethereum just transferred into from, they used to be proof of work. So instead of solving computational problems, now they're trying to get more investors into it rather than just people randomly mining for Bitcoin. So investors will kind of what's called staking a minimum amount of native coins. So for Ethereum, you would stake, I think the minimum amount is like 32 ETH to run your own node. And now with your staked coins, you're a valid validator. And now you're able to validate a block, and that's kind of run through your node. So you're not solving computational problems anymore, but you're more so just validating the transactions within the block. And then each block needs a specific number of validators as well. It can't just be one validator. So the reason for changing to proof of stake is it's much more energy efficient compared to proof of work, because you don't have a whole GPU rig just designated for mining. Now you're just kind of running your own node, and you're you're validating whenever you're needed, kind of. So it's almost kind of like picked randomly. So yeah, that's kind of the theory, a little bit more theory of blockchain. Again, make sure to kind of review the video after this and go into the topics a little bit further. I'm going to pass it off to Perry and Paul to kind of go through the demos now to talk about MetaMask and how we can kind of get some test ether from a faucet.
Thanks, Teddy. Yeah, so we're gonna start off with MetaMask. So it's like the most popular wallet extension in Chrome, and it's the easiest way to use and to interact with the blockchain on Ethereum. So MetaMask is, just keep in mind, it's a hot wallet. So that means it's connected to the internet all the time. So therefore, it is not the safest. I'll share you my screen here. Share. So yeah, so MetaMask is a hot wallet. So you don't want to keep funds on this personally for a long time. And I'll set it up for you. So what do you want to do if you want to keep funds over a long period of time? I would recommend you guys to get a Ledger, which is the most popular cold wallet. And the reason why it's called cold wallet is because they're not connected to the internet. So this is the safest way to store your cryptocurrency, and they accept most cryptocurrencies. So yeah, so we're going to start off with setting up MetaMask. So I'm using Firefox just because, and you just go to the website, download, and you got to add to Firefox. Okay, and I'm going to change my screen real quick. Okay, so I've added to Firefox. What do you go here? Wait, why is I realize it's like already connected. Is there a way to delete this wallet? I just realized this is
Should be able to. Is that your real wallet?
No, I just made a new one on this is an old one from Firefox. That's why I use Firefox. I was using Chrome, but
yeah, you can delete it. You just have to do it on like the MetaMask thing, but yeah.
How do you wipe this wallet? Settings. General. So I thought this was gonna be a new one because I had to like delete it. Paul, do you have an empty one by any chance?
Um,
Trying to remove this. Because it's not create an account because that's just the same hash.
It's the same one, yeah.
Right. Here, so
Import account.
what type? Is this a new thing?
You need to remove the extension.
I did. That's a thing.
Oh, and it still asked you for, oh, weird.
Yeah, see, it's like so weird. And it like remembers me. Oh, maybe I got.
Welcome to Meta. Yeah, there you go.
There you go. Get started. Okay, sweet. So here, so you go to MetaMask, make sure it's actually the MetaMask site, and then check the URL properly. You download, add it to Chrome mode. I'm using Firefox, it's the same. So if you have already a wallet set up, you could just press here and just write in the seed phrase. But here we're going to create a new wallet. Choose a password. I'll just go hello. Oh, yeah. Just create a random password. And then agree. And then press next. And these are just remember these 12 words are going to be pretty much your bank account password. So let's say you lose your computer, but you have these 12 words. You could just download MetaMask on whatever browser you want, put these codes in, you'll receive your fund. Like you get access to it whenever. So don't do what we're going to do, but normally write this on a piece of paper, not anywhere that's connected to the internet, just to be safe. Like Teddy wrote it on GitHub a few weeks ago and it got botted.
Don't write it. Don't write it on your phone. Don't write just
don't take a picture of it.
Pen and paper.
Yeah, pen and paper. And
or if you have one of those like what are they with the cold storage wallets? They send you like
A
a
sheet,
thing to
yeah.
put a sheet. You can put it
Yeah.
on the sheet too.
So I'm just gonna copy this to my notepad, but don't do that. I'm just making it fast. And then I'm gonna paste it real quick.
Yeah, because any attacker, if they ever get access to it and you actually have money in your account, it's gone.
Right,
It's your this is your private key.
right. So yeah. So I'm gonna put in the word one by one from my notepad. Well, salute, task, fence, memory. And I would recommend to get a cold wallet eventually, but hot wallets are fine, but just be careful with them. So yeah, so this is done.
Yeah.
And this is pretty
MetaMask is
much
good for development. Like it's really good for development, but
right. And it's
for-
just super simple
yeah.
to use. So yeah, this you could buy easily. You could send it if you have someone's wallet, super simple. So yeah, I'm gonna switch to my other screen now and I'll show you some cool extensions that are great for this. Yep, here we go. So some cool extensions are such as Ethereum gas price extension, which is great because then you could like keep track of the gas whenever. Because let's say the network's really busy. Let's say something was dropped, something's minting. You don't really want to send funds during that because it could cost you a lot. So that's the extension. And then, yeah, and then these are like the MetaMask is just the one for Ethereum. There's other ones such as Nami, which is for Cardano. This one's for Polkadot. So yeah, these are just easy extensions. Yeah. So I'll pass on to Paul. He'll talk about how to get Ethereum from a faucet, which will help us towards Solidity dev.
Thanks, Bird.
Nice. Let's stop sharing.
I'll share my screen and Paul will talk just because I have access to the faucet right now.
Yeah, so as Perry mentioned, we're going to be going over getting ETH onto your MetaMask account using a faucet. So on Ethereum, there's multiple different networks that you can perform transactions on. And whenever you perform a transaction, you have to pay something called gas prices. And it's just the fee of getting your transaction moved up onto the blockchain. So especially when you're doing development, you don't want to be testing your program and testing your contracts, I mean, on the main net, just because you're going to be spending a lot of like testing your contract. So test networks like Rinkeby or this one called Goerli, I think it's called, is really useful. And the ETH that you can get onto it is just like essentially made out of thin air. So you can use these things called faucets to send yourself this test ETH. And an important thing to note is that even though what we're going to do is we're going to be sending this test ETH onto your MetaMask account, which is using the same address hash, but you can't use that ETH on other networks like onto the mainnet. So you're not actually getting free money. It's just a way that you can use your account to test stuff. So there's a bunch of different websites and faucets that you can use, because the thing is also a lot of these faucets, like you can't just spam yourself to get like 100 of this 100 ETH on your testnet. So a lot of these websites require is just like you can get 1 ETH every 24 hours or something. So this one here is just goerlifaucet.com. And all you're going to want to do is just go onto your MetaMask and copy your address that you want this ETH to be sent to. And yeah, right there. And you're just going to copy it in to there where it says enter the address. And then you have to click send me ETH. And then it'll take a little bit of time. Usually it's about 15 seconds, the amount of time it takes to perform a transaction. And then once it's completed, you'll get, you can see in your MetaMask that you have 1 Goerli ETH.
Now you're fake rich.
Yep.
Now you're fake rich.
Yeah.
And we'll show you, okay, here it is. So yeah, it went from 0 to 0.2.
Yeah.
And then you can actually also view this on the Etherscan. So you can see, so this is the wallet address that it went to. This is my wallet address. So 9BE, 9BE, and this is where it came from. So it's kind of cool. And then here's the gas fees that Paul was talking about. This is fake ETH. But now if like so right now I'm on the Goerli testnet on my MetaMask, that's what I'm connected to. If I go back to the Ethereum mainnet, I have 0 ETH. So it's able to kind of compartmentalize the two, which is nice. But yeah.
Exactly. Yeah. So that's really it for getting ETH from ETH faucets. Again, there's we can post we'll post a link to this. I think it's on the presentation slides. But for now, we can move on to the next demonstration, which is Transaction Street. It's a cool little demo.
Yeah, so do you want me to share my screen or just use the screen?
You can just do
Okay.
mine and let's
Yeah,
just tell me where you
so
want me.
Transaction Street is just a really cool visual representation of how block validation works on Ethereum and Bitcoin, because Bitcoin's on the right side and Ethereum's on the left side. So think of the first top bus is the next block that's about to be mined, and each person, the South Park looking people, are pretty much transaction trying to be validated right now. And each house on the left could be any dApp. So the fox looking one is MetaMask. So let's say I'm sending money to Paul right now. A little South Park person of me would walk out of there and wait for the bus. So the top bus is pretty much what it's called as priority fees. So there's a base fee, which is like pretty much how busy the system is right now. And so you see the 14 gigajoule, that's the top bus. So the higher you pay, like the more money you tip the miners, the earlier bus you'll get into. So if you scroll down, there's some people waiting in these buses. So they don't really care too much how fast their transaction will go. But it's just like, let's say they're sending money, but they don't really care. They'll just pay the lowest gas fee and they'll just be in the back of like the last bus. But it'll take some time, but eventually we'll go through. And these are all the people waiting for them. So yeah, on the right side is Bitcoin. It works a bit different, but it's the same kind of concept. So yeah, that's just how it's a good visual. And you could press on each of the person, their actual live transaction. Like press on, yeah. So that's a person who's sending, his max gas is 38 gigajoules. He's sending Tether. So I'm guessing he's just sending some stable coins to someone. And yeah, these are actual live. If you press on Etherscan, yeah, there. So he just got validated. So you went on the top bus. So that's also a thing. Another thing too, before setting something, go on Etherscan gas tracker. It's a really good way to just look up how much it costs to send stuff. Yeah, you can just search up Etherscan gas tracker. And then, yeah. So that column right there, it tells you, see, like opens, like if you want to buy an NFT right now, it costs around $1.26. If you want to swap some tokens on a DEX with Uniswap V3, costs around $3. So this is a really great rate like before setting something, or let's say you're doing a first transaction. Yeah, you should definitely check the gas before you get baited, because sometimes gas could really spike and you end up paying way more than you should. But yeah, that's Transaction Street and gas tracker.
Yeah, but I think that concludes all the content that we wanted to go through today. Yeah, and as I said before, that this workshop's also recorded, so we're going to be posting that onto our website. If you want to go back and maybe there were some topics that you didn't quite understand or want to give it another run through, that'll be available. And hopefully the next workshop, that's supposed to be next week, I believe. Hopefully that one we're going to get in person, so we can actually have a better communication that way and see some real faces. So that should be nice.
Yeah. And thanks for everybody coming.
Yeah, if there's any questions from anybody, don't be shy.
Yeah, feel free to just unmute if you want.
No worries.